I got this great question from chapter 14.3 where we've got multiple regression. And this student got the model for the multiple regression. There's three explanatory variables and the slope or the y-intercept. And they found that when they did the first hypothesis test that it's definitely we definitely reject the hypothesis that all of the slopes are zero, meaning that at least one of those is explanatory. At least one of those variables is explanatory. Now the student was asking, because we're asked to test the explanatory variables one by one to see which of those three explanatory variables actually correlates well with the predicted variable, the y. So that actually comes from, you can do the same place that you got the model from also has the information on the individual variables. So if I just go to stat, regression, multiple linear, right? Because I've got more than one explanatory variable. And okay, and I just hit compute. It gives me the model I've got right here up here. Okay, this is just the regression model. But if you look down here, it also gives you the correlations for each of the individual variables, right? It's not correlations, but the hypothesis tests each of the individual variables to see if they might or might not correlate with the y value. Will have significant powers in terms of prediction of the y value. So for this first one, where we're asked to compute the p-value for x1 with technology, we just take the 0.042. .004. Okay, it's rounded to three places. Okay, and I think our significance is 5%. So what that means is that x1 it stays in the model, that it has predictive power in terms of the y. So we reject the null hypothesis, which is that the slope for x1 is 0, okay, or that it doesn't really explain anything. So we reject the null hypothesis. Let's see. It's one of these two. Reject the null hypothesis. The slope is significantly different from 0. So we're going to pick C. Okay. And then we just do for 2 now. Okay, our p-value there for the second variable is 0.0032, rounded to three places, 0.003. Okay, and again, that's below our significance of the 5%. So we reject the notion that the slope of x2 is 0 in the model, meaning that it doesn't explain anything. So we reject, and yeah, this one is significantly different from 0. Okay, now we just have to do the third one. This is the last variable in the model, last explanatory variable in the model. And we have a p-value of 0.247. So rounded to 248 to three places. Okay. You probably notice at this point that that's pretty high. That's well above 5%. So this, we do not reject the null hypothesis. We do not reject the null hypothesis, and B3, or the slope of x3, is not significantly different from 0, meaning that that's a variable we're probably going to dump from the model. Okay, so I hope that helped on this problem.